While the ethical dilemmas that underlie the self-driving car example we had earlier are clear, these types of jobs are relatively uncommon. But all software systems input, transform, and return data, and this data is often immensely valuable. There are also important ethical considerations that must be made when we think about how we're going to sell or transfer this data between organizations. Ultimately, we want to maximize the utility of the data we've collected while minimizing the disclosure risk to our users' privacy. An appealing approach to do this is through anonymization. Unfortunately, anonymizing data while maintaining its utility is not very easy to do in practice. So let's take a look at a concrete example. Imagine we're a health organization that has access to a wide variety of health data, and we want to make this data available to researchers who are studying the prevalence of diseases throughout a country. So here we have some data about diagnoses, outcome, and demographic data for whom these diagnoses and outcomes apply to. Now obviously if we wanted to anonymize this data, we would have to go and delete somebody's name, so we can just cross that off. But if we release this data on its own, it is still possible to figure out who each of these diagnoses and outcomes apply to. The way that we would try to de-anonymize this medical data set is through something called a link attack, and takes advantage of other publicly available data sets. So here we have a voter data set, which keeps track of all kinds of information about individual voters. It turns out if we take the zip code from the data set and match it with the medical data set, the gender, and the birth date, we're able to, at least in the United States, de-anonymize this data set for 87% of individuals. So now, even though we've gone and removed the name from the medical data set, for 87% of people we can directly tie these diagnoses and outcomes to specific individuals and where they live. One more advanced way to think about anonymizing a data set is through a process called k-anonymity. What this says is that an individual's record in a database will be grouped with at least k other entries when it is linked to other data sets. One way to do this is by transforming the data set to make it more general. So imagine we have a zip code, and the zip code in our data set is 98008. An easy way to transform this to make it apply to more records within the data set would be to change it so it's something like 98 blank blank blank. And in this way, many more records will be matched to this broader set of zip codes than this individual one. So while in this original zip code we might have had only one person with this birthday and this gender, in this new broader zip code, K may have increased to 8 entries, or there's 8 people with the same birth date and gender in this broader zip code. So in that way, by making this generalization, we've increased the K of this data set. Another important consideration for an anonymized data set like this is known as a homogeneity attack. So obviously if we have a k=1 data set, we can track an individual to their diagnosis, and that's obviously problematic. But in a k=3 data set, we have a concern if all of the diagnoses for those 3 entries are the same. So while we might only be able to put 3 different people and tie them to a diagnosis, we know that all 3 will have that same diagnosis. So the outcome is the same. We can still tie a person to their diagnosis even though the K factor is 3. As a profession, it's important that we make ethical decisions with the vast amounts of data that are at our disposal. As we can see here, it is important that we think really hard about how we anonymize this data before it's transferred to third parties or released to the public.